All right, 1.3.2, this exercise, all we're going to do is determine whether a statement is talking about a statistic or a parameter. If the measurement given is from our population, which makes it a parameter, or our sample, which makes it a statistic. This is crucial because as we move through the course, we're going to find that the calculations for different things are different depending on whether we have population data or sample data. Our standard deviation has two different actual calculations depending on which we have. And also we use different methods depending on what we're given. If we're given a population standard deviation, we can use a z-test, whereas if we're given a sample standard deviation, we have to use a t-test. So telling the difference is important as we move forward in the class. So I'll do the first one, and then I'm going to tell you guys to pause, as always, and try the rest on your own. So for the first one, it says the actual average height of all adult human males is 5 foot 9.4 inches. So we're trying to determine if this measurement, 5 foot 9.4 inches, is a parameter or a statistic. This particular value is a parameter. I'm just going to write P for parameter. Now, completely unrealistic parameter. There is zero chance that we would have the actual average height of all adult human males in the U.S. People are turning 18 and dying at any moment, and we have this. How would we even do that? We've already talked about, we haven't talked about yet, but the census it's an impossible thing to go out and get this data from everyone. So while this is a parameter, only by the fact that I've used the word all and actual to sort of denote that this is the real deal thing, in reality, we wouldn't be able to get this. This would be a statistic in reality. And I think I might have one question on the Blackboard knowledge check. I'm not sure if I put it on there or not, where I really have you think about, is this a feasible thing? Like, just because someone says this, in reality, there's no way that they have this. At best, this is a statistic, right? But for now, we're just going to call that a parameter because it does say it's from all, even if it's a completely unreasonable parameter to have. So again, take a moment, pause, try these on your own, and come back. So if you paused and came back, here are the answers. A lot of them were pretty straightforward, right? 60% of homes sampled. Obviously, this value of 60%, which is a proportion, is from a sample. We have, and I also want to talk a little bit about the different types of measurements we have here. In A, we have an average, right? Ooh, I did not mean to grab the giant pen. We have an average. In B, we have a proportion. In C, we have a count, right? The number of something. And these are the three big ones that we're going to keep coming back to throughout the course. These three big things that we measure and we try to infer about the population. The only one that I think, or the two where students have a lot of trouble, which I'll talk about briefly, are E and H. And that's because we don't really have the whole picture. So E says the average SAT score in California in 1990 was an 897. Well, it really depends what we're interested in, right? If I just want to know what the average SAT score in 1990 in California was, then yes, this is a parameter. But if I'm using California as a sample for the whole US, which would be a really crappy sample, but if I was, this would be a statistic. Or if I was using 1990 as a particular year to then infer about other years, then again, this would be a statistic. So E and H, if you had statistic for both of those, that's fine. I would not give you these questions on a test because they're unclear. It's not clear what the population was. I would have to say a researcher wants to know what the average SAT score was in California in 1990. So you would know it was a parameter. D also said sample. F said survey. And then G was another tricky one. Hopefully you thought about here what the keyword was. If not, take a moment, decide what word is it that should have let you know that this was a statistic. And hopefully after all that thinking, you realize estimates. Estimates means this is not the real deal value. This is a guess at what the real value is. This is statistics. This is inference, right? So Our keywords to tell us that we're dealing with a statistic, sample. We saw that in B and D. We also saw survey, which is another way to say we sampled. We didn't talk to everybody. And then we had this word estimates to let us know it's not the real value, it's just our guess at the real value, which is probably a word that we would have seen associated with A if A had been written how we would actually think of it.